I want to show you something. This is a picture of a note by Niklas Luhmann in his Zettelkasten. It has all the information right there. It's structured, it's organized, and everything has a reason for its place and position. In the 50s, when he first began on this exploration of an autonomous conversation partner, he really wanted the power of insight that happens when in the midst of an actual conversation with another person. This idea is the smoldering coals in which we want to light our fires with, the insights from dialogue. When I was first introduced to Zettelkasten, how to take smart notes, and Roam Research, I didn't see any innovative applications of the note-taking system. What I stumbled upon in the early days were reproductions, copying everything from the structure to how to lay out each individual note. It was applying the physical or analog slipbox in a non-distinct way. No one was actually using the technology that's been afforded us now. It was all duplications. It was all copy-pasting. It was all non-intuitive. And I say that with great admiration for what everyone's done in this field. Yet I think what was missing was an open-minded look at just what was happening. Roam Research is interesting because even with all of its apparent flaws, there's this huge cult-like community that has rallied under this note-taking tools banner for networked thought. As I began learning Roam and reading about Zettelkasten, I realized that there was something here. And I think it has to do with the fact that Roam is built on Clojure or ClojureScript. Now, mind you, I'm the furthest thing from a computer programmer, so please do your own research. But if I could say one thing, it would be that what Rich Hickey did, by the way, he's the creator of the Clojure programming language, but what he did was change the questions that were being asked. And if you change your question by asking a better question, you get a better answer. So let's ask a better question. How can we create a digital Zettelkasten with all of its apparent advantages over traditional folder hierarchies by maximizing the technological advancements that Roam Research offers? Let's go back to that analog note. You see that in order to view this note, no matter if you have them in the right sidebar or not, you still have to make it your main focus. And what we focus on means everything we aren't focusing on disappears. So what happens if we take that same information and instead of replicating, we apply the technological advancements in Roam Research and how it maximizes the power of the block? You see how that complexity is hidden behind simplicity? That's not a mistake, that's the point. If what we focus on makes everything else disappear, we ought to be incredibly diligent in what we are actually looking at. See, I'm an artist, and as an artist, we don't usually point directly to our sources of inspiration. But this time, I think it's worth showing what I was leaning on when I was wrestling with asking these better questions.
That's one thing. We need solutions to the field equations.
And the field equations, by the way, have just magically appeared behind you. So.
And look how simple they are.
Well, that's actually part of the question that I wanted to explore. I mean, it looks simple, but we physicists have this way of hiding complexity behind the symbols. And for this part, actually, I just want to take us through, because sometimes in these programs, you know, it is meant for the general person who just has an interest, but we'd like to sometimes do a little bit of the math. And if you don't like math, you can shut this part off. But let's just do a little tag team here. So this is the form of the Einstein equations. And if you're doing it a little bit more precisely, it has a few more symbols in it if you're not using the natural units that allow us to set certain terms to one. But even that, if we go a little bit further, is hiding this. So this is actually a more complete way of expressing the equations if we're now going to unpack the meaning of that first symbol, g mu nu. But then you look at that and you say, well, wait, what do all those individual symbols mean? This is called the scalar curvature, and that thing g is called the metric. And there's this little combination of them that gives you the scalar curvature. But wait, What does that really mean? Well, that's hiding this complexity right here, because we have this way of hiding the summation symbols within what we call the Einstein convention, using indices that contract in a particular way. So that's what that symbol means. And if you go a little bit further and ask yourself, what is the first term, R mu nu? That's the Ricci tensor, and it's given by this combination of stuff. But what's that new guy on the right-hand side? That's the Riemann curvature tensor. What does that equal to? Well, that's equal to this combination, where those gammas are known as the Christoffel symbols, and then you take those, and what are they equal to? Well, they're equal to a particular combination of the metric contracted with various derivatives of it. It's all just to tell you that this is kind of complicated.
It's the power of the block, and Rome Research just happened to be the first one to do it right.